Hello, guys. We're back today with our second ever Algebra 1 lesson. And you can see Chapter 1, Day 2. Today, we're going to be dealing with something called expressions. So, I know some of you guys are getting a little scared because we're starting to see some actual math on the page now. It's not just measurements and things like that, but don't panic. Even though we're going to be seeing some variables, we're going to explain kind of what that is. So we're going to take it one step at a time. And speaking of variables, I'm going to give you guys a few seconds here to just read over the standard, maybe underline some words that jump out to you, and we're going to kind of break down what we're going to be looking at today. Okay, so first thing, different parts of an expression. Let's talk for a second. What is an expression? What's the difference between an expression and an equation? Hopefully you got that right. An expression does not have an equal sign. It is as simple as that. An expression doesn't have an equal sign. Now, speaking of different parts of an expression, such as terms, factors, and coefficients, well, let's break that down a little bit. As far as terms are concerned, a term are going to be an item separated by addition or subtraction. Now, there's a very key difference here as to what makes something its own term, and that is there are no other like terms. So, for example, let's say, what do I mean by that? Well, let's say we had 2 plus 3. Now, normally you would say, okay, this is two terms, right? Well, even though we have an addition between them, they're like terms. Because what do we know 2 plus 3 is? That's 5. This is just one term. 2 plus 3 is really one term. It's 5. But what if I were to tell you 2 plus x? Well, you can't add 2 and x. They're not like terms. So this would be two terms. 2 is one term, and x is the second term. All right. Now we've got coefficients. That word sounds really scary. All a coefficient is, let me bring this over here. All a coefficient is, guys, what an ugly way to write that word. A coefficient is just a number in front of a variable. So an example of a coefficient, if I had 3x, the coefficient would be 3. That's all that word means. So take a quick second. I feel pretty confident with you guys in your ability to identify mathematical operations. We're talking plus, minus, multiplication, and division. So real quick, you can use shorthand abbreviation. Tell me whether we're adding, subtracting, multiplying, or dividing for these four. I'll pause, and you can unpause the video when you're ready. So I've got a very good feeling. You guys absolutely crushed that. Now, if there's one thing I hear a lot in math, especially from both parents and students, it's that math wasn't too bad until you started introducing letters into the mix. But again, we just have to understand what those letters represent. And I know most of you guys are going to know what this word is. We're talking about a variable. You've seen this word before. And all a variable is, all these letters are, they just represent a value. And here's the thing, they usually represent an unknown value. That's why they're a letter. That's why we can't put a number there, because we just don't know what they represent. And I'm not going to insult your all's intelligence. I feel pretty confidently that you guys could circle the variable there if I wanted you to. But here is where we get into a little bit of definition action. Maybe some definitions you haven't heard of. So there are two kinds of expressions. We have algebraic expressions and numerical expressions. So you can pause the video and read these two and be ready for a question here in just a moment about these. All right. Look at some of the stuff we've underlined and circled here. Algebraic expressions involve one or more variables. Because whenever we talk about algebra, algebra kind of implies variables are mixed in. There's something we have to solve for. Now, numerical, you could probably piece this together. That just involves numbers and operations. No variables at all. So real quick, if you want some practice, I'll pause the video. Write an N or an A, depending on which one of these you think are numerical expressions or algebraic expressions. And when you're ready, you can unpause the video. Did you go 4 for 4? Like Wendy's? Ugh, I just cringed in my seat. I hope you did. We can see that 3 of these 4 involve at least one variable, and so 3 of the 4 are algebraic. Now here's where we're going to spend the rest of our day. And this is a part that sometimes certain phrases can kind of mess with people a little bit. Because next we're going to talk about what happens whenever we have an expression that's been worded, not necessarily shown through numbers and actual math. How can we tell what kind of mathematical operation we're dealing with? So let's look at number 1, more than a number. What are you guys thinking? I feel like Dora the Explorer again. We're talking addition. If I go 5 more than something, that means I'm adding on 5 to something. Well, if you got that, you probably know for sure what less than a number should be the word less than there. We're talking subtraction. The sum of 2 numbers. That word sum, we're talking addition. Fewer than a number. Fewer, if I'm 3 fewer than 6, that means I'm at 3. That is subtraction. The product of x and 4, that would be 4 times x or x times 4. We're talking multiplication. And the quotient of 2 numbers, we're talking quotient, means to divide. So we're talking division. Now, I'm going to let you guys practice numbers 1 through 5, and you can unpause the video here in a couple seconds, just if you want some extra practice. But 1 through 5, this will be great practice for us. So you can unpause the video and just double check before we get into a little bit harder stuff here. Okay, so hopefully we went 5 for 5 on the operations, but here's something else I want us to look at. I know I said that writing these was just extra practice, but something that isn't extra practice is we need to write out the mathematical expression. And this is where some people can kind of start to struggle a little bit. So we know, for example, on number 1, the quotient of 6 and a number is division. How would you write this out, though? Well, if we're dividing 6 by a number, we'll have 6 divided by, or you could write it, if you want to, like this, 6 over, same thing. But wait, what's a number? Oh, if it's a number we don't know, that must make it a variable. So I'm going to choose, let's not be boring, I'm not going to choose x for our variable. Let's go a, the second most boring variable choice. You could write this as 6 divided by a, or 6 over a. That's the same thing. How about number 2? n times 12. Well, if we're going to write this, and if you have a number multiplied to a variable, you never ever put the variable first. We got 12 times n, or just 12n. The sum of a number and 59, once again a number, I'm going to use my favorite letter, C, and 59, C plus 59. 18 more than 6, be careful, 18 more than something. So if we're more than something, we start off with the original something, that's 6. And if we're going 18 more than 6, we know we're adding 6 plus 18. So we're taking the 6 and adding on 18 more. So be careful. This is said backwards. And following through with that, how about 8 less than a number? Same idea. We start with a number. Let's call it t. If we're 8 less than that number, we know we're subtracting 8 from t. That's the number one mistake people make, guys, is they forget that more than and less than means you kind of have to write these backwards from how you're reading it. Now I'm going to let you guys practice 1 and 2 for me. Same idea. You don't have to write what the operation is, but you are going to write what the algebraic expression is. So take some time. You can pause the video, and when you unpause it, let's see if we got the right answer here. So hopefully you didn't get number 1 backwards here. If we're 3 fewer than y, that means we have to subtract 3 from y. So y is our starting point here. Now division, we can read this a little bit more straightforward. The quotient of r and 12, well, that's going to be r divided by 12. And then here is where things can get a little bit tricky. We've got more than one thing going on here on numbers 3 and 4. 13 more than, okay, if we're 13 more than something, we know we're adding 13 onto an original entity. What are we adding 13 onto? 13 more than the product of 2 and j. Ooh, now product, if you remember, that means multiplication. So the product of 2 and j, we got 2 times j plus 13. I really should have put those closer together. There you go. 2 times j plus 13. Mark that out. Space that out a little too much. And I bet some of you guys are thinking, okay, I can handle number 4 then. Let me try it. Then don't look at the paper as I work. How about that? 8 less than, so we subtract 8 from the original quotient of 4 and p. 4 divided by p. And remember PEMDAS, we would do the division, then the subtraction, if we could. All right, so guys, let's pause, stand up, stretch, take a break. Just be ready for some additional questions and for just a final wrap up. We are almost there. We're on the home stretch. All right, so guys, we got 2 more of these left. Then I'm going to give you a chance if you want some additional practice. I will flash 1, 2, 3, and 4 up on the screen here in a moment. But before we get to those, we still have 2 problems left to do at the top of the page. 1/5 of a number q and 4 more than 5 times w. So let's start with the one that may sound a little bit more confusing. 1/5 of a number q. What does it mean to take 1/5 of something? 2 things, really. This could be a division problem, or you could make this a multiplication problem. Let's talk about the division way first. So if you're taking 1/5 of something, wouldn't that mean you're dividing it into 1/5? You're dividing it by 5? So we could take q and divide it by 5. Q over 5, that's taking 1/5 of something. Or we could actually take the fraction 1/5 and apply it to q, and you would apply that through multiplication. 1/5 times q is the same thing as q divided by 5. Both those are 1/5 of q. Number 6, a little bit easier. 4 more than 5 times w. Oh, there's that more than phrase, so we know we're adding on 4 to something. The original is 5 times w. All right. And if you would like to try 1, 2, 3, and 4, which, guys, I would strongly encourage you to, I'm going to flash these up on the screen in a moment. And so just if you want to, go ahead and get some practice in. If not, be ready to hit the last section. So hopefully you guys are feeling pretty solid about 1, 2, 3, and 4 there. All right, last section of the day. We're going to flip the script a little bit. And for those of you who hate to write, I may have to apologize ahead of time. But I tried to make it as easy on you as possible. So I'm actually going to help you guys do 2 with me. And that'll leave you with 4, 5, and 6 to practice on your own. So we are going to write a word phrase for each algebraic expression they give us. So for example, they gave us x plus 8.1. And one way I might write it is the sum of a number and 8.1. That's all there is to it. How about number 2? We got a couple things going on here. If we're adding 9, then we know we are doing the good old-fashioned more than situation. So 9 more than, so we've added the 9. What was our original? Oh, 10 times x. To times means the product. So 9 more than the product of 10 and x. And I'm going to let you guys take the next few moments. You can pause the video and you can work on 4, 5, and 6. All right, let's see what you guys think about 4, 5, and 6. I've got those 3 right here. And also for you overachievers, I had a feeling some people might try number 7. And yours may not look identical to mine, but hopefully it looks kind of similar. Some of you, though, may be thinking, wait a minute, why did you do the sum of y in 3.3 before you multiplied? Well, order of operations, PEMDAS. We do what's in parentheses before we worry about what's on the outside. So we're doing the sum of y in 3.3 and then taking that sum and multiplying it to 0.5. And let's finish with this. We want to be able to write an algebraic expression for a real-world setting, right? What's the point of learning some of this if you can't apply it to the real world at all? So we're going to write a rule in words to kind of model this relationship. And so I'm going to give you guys a few seconds here, read over the situation, and then let's see if we can piece together maybe an expression to model this relationship. So we can see that we are paying $9 for each hour we use this bike, along with that one-time $5 rent-a-helmet cost. I've got a feeling some of you guys have already started to see the pattern here. 9 times 1 plus 5, 9 times 2 plus 5, 9 times 3 plus 5, because we need to multiply $9 times the number of hours, which is in. So if this is the number of hours we're renting this bike, what could be an expression we could write that could represent any number of hours that we rent this bike? Well, I like the formula they have here. 9 times, not 1, not 2, not 3, but n plus 5. $9 times the number of hours you rent the bike plus the $5 for the helmet. And so you would say we're going to be paying 5 more than the product of 9 and n. And so guys, just be ready. Maybe some delta math coming your way today or even this weekend. We'll see. I know it's the weekend, so I will be sure to let you know through Google Classroom. So just stay posted, and I'll see you guys soon.